For problem number 1, locate the centroid of the plane area shown. So, dahil number 1 natin, number 1 problem ay mayroong dalawang shapes, rectangle and this half circle. So, ang hinahanap natin ngayon ay ang x bar at saka y bar. So, para madali natin mahanap, so area of square. So, for rectangle, and this is for half circle. Ang area ng rectangle ay 1,500. 30 times 50 is equal to 1,500. And for number 2 is equal to negative 353.43. So, for x bar, meron tayong meron tayong 15 and 23.634, and for y bar meron tayong 25 and 30. And for x bar a, so meron tayong 22,500 sa rectangle, and sa half circle is we have negative 8,353. And for y bar a, meron tayong 37,500 and negative 10,602.9. So, itong dalawa na to ay kukunin natin yung mga solution nila para sa mamaya kunin natin yung x bar at y bar. So, sa x bar meron tayong 14,147. Sa y bar, x bar, sa y bar meron tayong 26,987. And for the summation of area for both is summation is equal to 1,146.57. So, kukunin na natin ang x bar is equal to summation of x bar a is equal to summation of a is equal to 14147 over 1146.57 is equal to 12.34 inches for x bar, and for y bar, summation of y bar a over summation of a is equal to 26987 over 1146.57 is equal to 23.5 inches. So, ito yung value ng ating x bar and y bar. Problem number 2. The truss is made from 5 members, each having a length of 8 meters and a mass of 14 kg per meter. If the mass of the gusset plates at the joints or the thickness of the members can be neglected, determine the distance A to where the hose link cable must be attached so that the truss does not rotate when it's. So in problem number 2, we should determine the distance of A to where the hose link cable must be attached so that the truss does not rotate when it's lifted. So we should summation of x curly n is equal to the length 8 times the mass, which is 14, times, since there are 5, 1, 2, 3, 4 plus 5 is equal to 1,680. So the summation of m is equal to 8 times to the mass times 5 is equal to 560. So we should D is equal to X bar is equal to summation of X curly M over summation of M. So this is the formula to get the distance. So 1680 divided by 560 is equal to 3 meters. So this is the distance of A to where the hose link cable must be attached. So the slender rods have a mass of 8 kg per meter. Determine the moment of inertia of the assembly about an axis perpendicular to the page and passing through point A. So here in problem number 3, we're looking for the moment of inertia of the assembly about an axis perpendicular to the page passing through point A. It is our slender rods. So now, in solving slender rods, we have IG, inertia G is equal to 1 over 12 MI LI squared. So, but before this, we should first get the MI. So MI is equal to 8 kilogram, the mass of slender rod, times 2 meters. So it's equal to 16 kilogram. So getting the inertia of A is equal to summation IG I plus MI squared is equal to 1 over 12 times 16 times 2 squared plus 16 times 4 squared plus 1 over 12 times 16 times 2 squared plus 16 times 2 squared. So just multiply it to 61.33 plus 69.33. So just add. So now we can get the moment of inertia. So the answer is 330.66. So 330.66 is the moment of inertia of the assembly about an axis perpendicular to the page and passing through point A. Determine the cross-sectional area of the product of inertia about the X and Y centroidal axis. So here at the next problem, the cross-section can be subdivided into 3 composite rectangle areas, which is the A, B, and D. So for A, we should A in Y is equal to 1 plus A dx dy. So due to symmetry, the product of inertia of each rectangle is 0 about a set of x1 and y1. So x1 is equal to 0. So this is 0. So letter A is equal to 300 times 3 times 1 times negative 2.5 times 2 is equal to 15, and for B, I is equal to 0, because as we can see there's no value for the xy is equal to 3 times 1 times 2.5 times negative 2 is equal to, by the way, this is negative, this is negative, so this 3 is the answer. So the negative result is dahil ang rectangle A and B ay may centroid na nasa negative x at negative y coordinates. So we have now in the another problem, which is determine the moment of inertia for the shaded area about the x-axis. The area of differential element parallel with the x-axis, inertia x is equal to a y squared d. A is equal to, so now we have y squared times y squared dy, 0 to 4 inches. So it's equal to y to the 4th dy 0 to the 4 inches. So y feet derivatives 4 inches 0 is equal to 204.8 inches to the 4th power, or 205 inches to the 4th power. So this is the answer.